Okay, we'll start then. They're kind of not here or whatever. Okay, so today we'll be doing more programming. So how, like, what data science actually is when you like work inside industries and stuff. Okay, so does everyone have like Jupyter notebooks open or Kaggle? Yes, no? So if you remember, if you don't know how to open Jupyter Notebooks, if you type in, like if you have Windows, just type in start, and if you just type Jupyter Notebooks, you'll get it. If you install Anaconda Python. If you're in like Ubuntu or Mac and stuff, just terminal, right? You just type terminal, and it should look like command prompt. But then you just type in the same like Jupyter Notebook, and then you just press enter, and it should work. And once to open it, you go to your web browser and you just type localhost. I think it's 88888 or something. Anyways, just go inside your web browser and it will open. But if you don't have Jupyter Notebooks, you should go to Kaggle. So you go to Kaggle, and you have to make an account. And if you did, you just go down. You just sign in. You're going to just sign in. And then when you sign in, you click kernels. And then you just scroll down and press new kernel. And then click notebook. And then today we're going to use the Titanic one, so you should go to the Titanic one. So you just type in search Titanic. So just just press just do this one, just ignore this really, whatever, someone else's. And then once you load it up, yeah, you'll see something like this. So, yeah. So this is what your environment should look like. For Jupyter Notebooks, it will be similar to this, and for Kaggle, you'll be using this. I'll be just using Kaggle. So in data science, there are three main libraries you need to know. The most important one is NumPy, right? And what is NumPy? Or you can call it NumPy, whatever you like to call it. NumPy is your linear algebra library or your maths library. So we want to import that, and Python, the import function, will let you import. Okay. Your other libraries which are very important is pandas. And what is pandas? Pandas is for data frame manipulation, so for tables manipulation. And the other library which you need to know is scikit-learn or sklearn. And scikit-learn is your machine learning library, which is for your random forests, so for machine learning. Other libraries which you can use include like the plotting library, which is called matplotlib. Right? This is called matplotlib. .pyplot, because you don't have to do .pyplot, but you have to keep calling it like that, which is annoying, so that's why you just do .pyplot. And this is your plotting library, so you want to plot graphs and stuff, this is what you need to use. Other libraries which you also might need to use include, there are also other libraries like Seaborn, which is another very cool plotting library. So you can use that as well. And so those are the major libraries which you will use if you work in the data science industry. However, there is a problem with this. If I import the library, right, I have to call it every single time. So if I add a new cell, so remember to add cells, and to execute the cell, just Control Enter. So you press Control and Enter, and it will execute the cell. And then you go to the next cell, and you just Control Enter. So it will execute the cell. Anyways, if I do this, right, it's not very good, because if I just import the library, I have to keep referring back to it. So numpy dot, right, determinate numpy dot array, right, or matrix. or maths matrices, matrices, right? You have to keep referring it like this. This is very annoying. I don't want to keep typing this, right? And if you want to use like pandas, you don't want to keep typing pandas dot data frame, right? This is very silly. So what you do in Python is you can refer the library as something else. So the convention in is NumPy will be called NP. Pandas will be convention called PD. Scikit-learn convention is SK. And matplotlib.pyplot will just be called PLT. Right? These are the conventions. You need to remember these conventions. Like you can call it whatever you like num. Right? And pandas can be PS or something. But if you read like other people's code, you should keep the conventions the same. So these are the conventions you need to remember. Right? So once you call that, if you do Control Enter again, right? You can call this now, just PD, and it would work instead. And NumPy will work. Oh no, there's no such thing as that. But this will work, right? You don't need to keep calling this. It's very annoying. So now you can just reference it very easily. So that's good. However, there is one more thing you need to know. What happens if you want to import the entire library without even calling NP, right? You just want to call that. Or you just want to call this. Instead of typing DD dot, right? So if you want to do that, what you do is you use another method, which is you use something called from, right? So from the library, we want to import everything. So like for example, from NumPy, import everything. Everything is the everything is the start, right? This asterisk, and the asterisk means I don't care which function, just import everything. So if you do that and you press Control Enter, right? You don't call this anymore, right? You don't need to call that. You just call matrix, and it will work. So if you want to do that, you can do that, which is for easier calling. So you can do it like from pandas, import everything. It will take some time because it has to go through the whole pandas. And then now you can just call this. And yeah, so this is for easier for you if you want to do. Also, also there's one more thing. You can call things on one line. For example, if I want to import NumPy as MP, right, the convention, I can also do comma pandas as PD as well. I can just do that, and sklearn as sk. This will all work. Right, so Python is very, very flexible. You can do this if you want. So you don't need to keep writing the import word 3 times, so you should do that. Okay, so anyways. So once you import the libraries, right, now we're going to get the data in, right? If you don't have the data in, what's the whole point? So we're going to use pandas, right? So we're just going to use this convention PD dot. We're not going to use the easier ones, right? Not this, because you will get confused. So I'm just going to use PD dot, which is referencing pandas as the package. So if you have Jupyter notebooks, remember to put your Titanic dataset, I think we told you before, in your directory, exactly in the directory. So to download your Titanic, if you don't have it, what you do is, where is the Titanic? Oh, that's the small. Anyways, download. If you don't know whether, so does anyone not have the Titanic dataset? It's called train.csv.
Where do you put it?
It will be on Kaggle, but if you don't have it, you can go to.
I get it from GitHub. When you put it in your directory.
Put it directly in the. So you're using Jupyter notebooks?
Yeah, on the map.
Okay, so when you press new, where was the directory before?
Make sure the file is in the same directory as your notebook. So where's the notebook?
You should once again on Kaggle.
Oh yeah, give me a second.
In the same directory.
If you have
Your CSV file is in here.
So if you have Jupyter notebooks installed, so not Kaggle, and you don't know where the train.csv is, go to this website, right, the GitHub, and then go to and then once you go there, this is what it will look like. So I'll keep it up again. Yeah, it's fine. No one else needs it. So once you get that, you just download. There's a train.csv on the bottom, right? You just download it. So you open it, just click on it first, and then you click, you just click raw, and it'll look like that. So you right click on the raw, and you click save link as. So you put it like wherever the Jupyter Notebook is, if you know what I mean. So whenever you open Jupyter Notebooks, it will show you all the like folders and stuff. Put it exactly where you find it.
Oh, we don't have Jupyter.
Yeah, we don't have, unfortunately.
But yeah, wherever your .ipy,
Yeah.
wherever that file is, make sure your CSV is in the same directory.
Yeah.
Can you just upload it using Jupyter as well?
What do you mean? So.
Like there's a, on the top right.
Oh yeah, you could also do that. Yeah, correct. You could also do that. So the upload, yeah, that's also very good. Anyway, so in Kaggle, so if you have Jupyter Notebooks, not Kaggle, just Jupyter Notebooks, to import your data, because this is a CSV, you type read, right? Read pd.read CSV, and the file name. So this is for Jupyter Notebooks, no Kaggle. The file name is called train.csv, and just Control Enter, and you should see. Oh wait, no, don't worry, it's not going to work here because it's not Jupyter Notebooks. But this is for Jupyter Notebooks. It should work if you put the file in the correct position. For Kaggle, you need to do // input / and then you, yeah. So // input /. Okay, this is for Kaggle people. And this is what your data will look like. Right? It will show you the table. Passenger ID, survive, B class, blah, 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 all of this. Right? So, however, we don't want to keep doing this, so we have to assign it a variable. So I'm going to call it data is equal to. Okay? And to assign it, now we can call data. Like we can just call the data. Right? And you see the table. In statistics, you'll probably hear summary statistics like mean, mode, median. So how do we do that? How do we like summarize it? You just do .describe. Right? You just want to describe the data, and you have to put these two brackets things, and then you do Control Enter. Right? And they describe it for you. So the count is how many variables that are not missing, passenger ID, blah, the mean, the standard deviation, the minimum, all of this, right? Now, the question is, what happens if I don't put that, like, two brackets? What will happen? It'll look like something like this. Right? Not good. So we have to put the two brackets in. Okay? So this is your data summarized. So as you can see, age is only 714, right? While the other ones are 891. So that might cause a problem. Also, so let's say I want to count how many variables there are, right? So I want to count how many rows there are. So in Python, what you do is len. Len means length, right? And to do the len, it should be 891, right? This is the length of the data. So you could also do this. Let's say you want to count each column how many rows there are. So you do .count. And as you can see, age is 714. Cabin is 204 and embarked is 888, right? So this means there's missing data. That's not good. If there's missing data, you can't really do anything because the system does not understand what is NA or what is like dots or what is commas.
Yes, as you can see, the reason why we don't have 891 for age or embark or cabin, you can see that there are missing values here if you open up the file in Excel, and that's not good as incomplete data can cause problems when you're doing the actual machine learning algorithm. So what we do is we find a way to fill these missing values in. That method's called imputation, and there's many ways of doing it, but today we're going to fill in these values with the median, or mean, either or.
So what Saksham was saying was the missing data is not good. Also, if you open your CSV file, step 1 normally of the data science process, right, you should actually open it in Excel. So you should see what it looks like. So as you can see, so what does anyone know what P class means? Like what's 1, 2, and 3? What do these numbers even mean? Does anyone know? Okay, so what does 3 mean? What's 3? What's like how does it compare to 1? Which one's the best?
First class.
Okay, yeah,
Yeah,
good.
first class.
Yep, so first class, second class, and is there a fourth class? But how do we not know that? How do we know that there is no fourth class?
You can like filter it.
Yeah, we can use that. Yep, good idea. So we can press the filter button, right? And then you can see there's only 1, 2, 3. But how about if I want to do it in Python? Because what happens if there's 10 billion rows and I can't open it in Excel? How am I going to check? So do you have any suggestions, anyone? Huh?
Print the max of the column.
Print the max of the column. Okay. So to reference columns, this is what you do, right? So let's say that I want another P class, right? So to reference it, it's just that. This is to reference P class. This is how you reference data in Python, right? The 2 square brackets. So you said to print the maximum. Let's try that. So you just do max. Okay, 3. Okay, yeah, that's a good idea. But what happens if it's not numerical data? What happens if it's like male and female? How do I know that there's only male and female? What happens if there's other? So what am I going to do? Yeah, you can loop through it. You can loop through it and print the ones that are not like you haven't seen. But wouldn't that be very time consuming? Right? You have to loop through the entire 10 billion rows. So what you do is this. You can do dot unique. And it tells you all the unique values. Okay, so yeah, this is what you do. So the unique function will tell you what is unique inside the data or the column. Right? You can't do this. You can't just reference data.unique because that wouldn't work because it's not a column. What does this actually mean? So the program will fail. So you have to reference each column to find how many uniques there are. So this is important. This is very important actually. Also, how about if I want to know how many there are? Like how many males there are, how many females there are. So what we do is we type the value counts. And this is how many males and how many females there are. Right, you can also do like, age, let's do. Well obviously age, this is continuous, but you can see some of them are duplicated, right? So yeah, so this is important as well. Anyways, so what Saksham was saying was imputation. So in a data set, we do not like variables which is not full, right? Look, age is not good. Kevin is not good and embarked is not good. How do we fix this problem? Does anyone have a suggestion? How do we make this 891? Because we can't do anything. We can't do anything if there's missing values. There are around like 2 methods you can do. Does anyone have the first idea? What's the first method? Okay, fill it in. Yeah, that's one method. What's another method? Yes, delete it. Good, right? So let's do the delete one. It's called drop NA. Delete everything. Delete the rows that are not complete, right? And let's see the count. Let's do the count. How many there are? Right? There's 183, right? It will be the lowest number, which is like full, which was Oh wait, yeah, because sometimes rows can be full, like one missing. So it has to delete the whole row. Must be 100% not full. So that's why it says only 183. Anyways, this is one method, which is to just destroy the rows which are missing.
Why might we not want to do that? Why would that not be ideal?
Yeah, good question. Why do we not want to delete the rows?
Because you're losing somewhere around 80% of the data.
Yes, correct. Very good. We're losing lots of data. So what is another method? You suggested filling values, right? So
we use pandas for that.
yeah. So there are multiple ways to fill data.
Just do pd.fillNA.
Oh, it's just not filling.
All right, you import it.
Oh yeah, don't worry. Do it. Oh, do you want to do it?
Yeah, you stand up.
No, it's data.fill. And then just type just do 0. Just do 0. Just do 0. Okay, yeah. So we want to fill the missing rows with 0, right? So now all the missing rows will have 0 as the missing value imputation, right? So is this a good idea or a bad idea? Should I fill it with 0? Or should I not fill it with 0? Anyone have a suggestion? Or what else should I do? 0 is not a good idea, right? Obviously 0 is not good. What else should I fill it with? Yes, very good. Average, right? So how do I do average? You just write data.mean, right? Mean is average. So you fill it with the mean of each column. Also, oh wait, let me show you what data.mean looks like. Yeah, that's
But what if the
Yeah.
data is not
not continuous. Yes, very good. Yeah, very good point. So it won't take the mean. So I'll show you. What is the mean, right? So the mean will only get the continuous variables, right? Cabin, they don't know what the mean is. So this will only fill the continuous variables. So how do we know which one's continuous and not continuous? We type D types. Oh, wait, this time it's not the thing, right? So D types tells you, so this is integer. Name is object. Gender, object, age, float. So float is also a number, just with decimals, right? So you're saying, how do we fill these objects, right? So that's the question. So what we can do, okay, so normally, to fill NA, there are multiple methods, but you can also do median if you want, right? The median. But normally mean and median. There are other methods, but don't worry about them. So now we're just going to use median because normally median is more sound-worthy because if the data is skewed, at least the median is not skewed. So we're going to fill it with the median, right? But still, if you check the count, right, age is going to be fixed, right? Age is fixed, but embarked and cabin is not fixed. So can someone suggest me another scenario? Like if I want to fill the object data, what am I going to do? What is the main method I'm going to do to fill these objects? Like cabin, what am I going to fill it with?
You can look at your Excel file for idea, CSV. So we want to fill these values in. And the data is not continuous, so how would we fill that in? Like if I wanted to know what the cabin name of this was.
Yeah, what am I going to do? Anyone have a suggestion? Oh, no, wait, let's do the easier one. Embarked only has 2 missing. What am I going to do with embarked?
the value which is most frequent.
Yes,
Yeah.
very good. Exactly.
The mode.
Yep, the mode, right? So the mode will be obvious, but it's not a good idea to fill the cabin with the mode, right? Because how many is missing? There is 600 missing. You don't want to fill the mode with the cabin. But you can fill the mode with the embarked, right? So remember to check. Right, so remember this means the mean, right? This is the median. So what's the mode? But however, it does not look the same. Right, look, I'll show you. If you do mean, it looks like this. How come mode looks different? Right? What this means is that when you call the mode function, it will also treat the missing variables as also like a type of mode. Right? Because they will treat this as like a string or a character. And that's why when you call it, it looks something like this. So what do we want to know for the mode? We just take the first line. Okay, the first line is the one which is like not missing values, right? So to call the first line, you have to reference the first line, right? So you can't do this. You can't reference the first line. Why? Because remember before, remember, what is this? Right? This is to reference columns, which means we can't reference rows by just calling 0 or row 800. Right? We can't do that. So instead, we need to do .ilocation, iloc, right? And this will reference rows. So you need to use that. So if you go back, data.mode, right? You have this, but I want the first line. What I want to do, so .iLocate 0, right? The first line is 0. And then once you do that, you'll get the mode, right? So this is to fill the mode. But how do we do that? How do I fill the mode in? So remember, I already filled the continuous variables, right? So what's next? I do .fillNA, right? I already filled, so the first part, this part of the data is already filled. Now I want to fill the objects. So just to fill NA, you just call it again. Right? Data.mode, remember we want to fill the mode. .ilocate 0. But there's a problem with this. Because remember I told you if it was cabin, I don't want to fill it with the mode. Because look, cabin has so much missing variables. Can someone tell me what do we do with this then? How do we fill the missing variables for this? Any ideas? So what you do is you can fill it with missing data, right? That's the best scenario. You just keep doing that. Because I don't know what else to do, because there's 600 missing, maybe the missing says something. So we need to put it with missing, right? So you keep doing that. So how do we do that? Well, look at this. If I fill the mode in, right, that means the cabin will also be filled. Which means I need to fill the cabin in first, and then I fill the mode. So how do I do that? So we reference the data that is already filled continuous by X. Right? And then we want to fill cabin. So cabin, right, we reference cabin, and we want to fill cabin with missing. This is what it will look like. Okay? What this means is you're updating the column cabin by filling it with missing. And if you do Control Enter, you fill the cabin with missing. And then we can fill it with mode. Right? And then you can do x.fillNA mode. So step 1 is to fill everything with your median or your mean, right? Step 2 is to find the elements, find the columns, right, which have too many missing. And if it's too many missing, we will just say it's missing. So the missing values will be directly missing. And then finally, we fill it with the mode. And then once you do that, all your data is cleaned. So if you do x equals x, dot. So if you do the count again, right, it will be 891, 891. So we filled everything. So what does the data look like? So if you call x, so look, cabin will say missing, 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 which is good. Embarked will be filled with the mode, and everything else will be filled with the median. So does everyone get that for cleaning? Yeah? So obviously there are other methods, like, don't worry about it, but there's like, you can try to, maybe sometimes people do fill the maximum or fill the minimum. You can also do that, right? There's all the other methods called algorithm imputation, like mice and stuff. Don't worry about that yet. But this is important. So this is normal filling. So this is what you would do normally in a setting. Okay? So let's say that we filled everything in. What are we going to do next? Let's say that we filled all the data in. Does the algorithm understand what this is? Does the algorithm understand what's male and female? So what are we going to do? How are we going to make this into numbers? Anyone know? Or do you know the statistical term, or anyone does like statistics? What is the process called? I want to translate this into numbers. Sorry?
Factorization.
Yes, factorization, yeah, you can, yeah, correct. Any other words? You can, yeah, factorization is correct. So you can factorize it out and you can put different columns and stuff. You can,
use it as values.
yes, so what do you mean? So like,
So just male and female would be two different values.
wait, sorry? Male?
Male and female would be two different values.
Okay, male, yeah, okay, like, what do you want to choose? So what's male? What do you want to choose male as?
Any value, let's say like a number.
Like 10?
Yeah, 10.
So all the males will be 10.
10.
And females will like be 200, something like that, yeah? Okay, yeah, good, yeah, you can also do that. That's called dummification, right? You want to make dummy variables. So, you can do that. In convention, what we do is we make male to 0 and female to 1, right? And if you see another one, it'll be 2 and 3 and 4. So, how do we do that? So, remember, there are two methods. There's the factorization method, which is trying to put new columns to factorize it out. So if there was a male, it would be 1, 0, 0, 0, 0, 0, 0, 1, right, if you see a male. And the other method is called dummification, which is changing the males to 0 and changing the females to 1. So there are two methods you can use. Which one's better? Is trying to get male into a new column better, or is trying to change zeros and 1 better? So what do you think? Which one's better? Or it depends on the scenario, but which do people normally do?
Put into columns.
Yes, put into columns. So how do we do that? There's a function called pd.getDummies. Right, and you just call it like that. And then once you do that, see the name are splitted, right? For each name, it will do like a on and off. So it's called a one-hot encoder. If I see the name Abbing, right, I'll put 1. If I don't see it, 0. See, all of it is 0, 0, 0, 0, and so on. Right, let's try. Oh, it can't. Good. Anyways, so look, it keeps going. So all of this is imputed, right? So embarked is C, Q, and S. So this is called. So this is factorizing, or you can call it dummification. Sometimes people get the words confused, but that's okay. Now the question is, should I do this on name? Right? Should I make a separate column for each name, or should I not? Because if you see in name, if I do Abbing, Mr. Anthony, right? There's only going to be one in the whole column. So should I do this to the name column? Yes or no? No. Okay, so we're not going to do that. Right? So what you can do is you can reference it like this. Columns is equal to, I just want to get the columns. Right? So, I need to add a new one. Okay, so X, right? So which one, can someone tell me which one are the categorical variables? So P class is one, right? So I want to know, I want P class. Anything else? Name, no, right? I don't want to like put every single column name, so that's bad. So I don't want to put it in. This I want, right? What else? Does anyone know what SIB-SP means? So SIB-SP is sibling, right, and spouse, I think.
Yes.
Yeah, sibling and spouse. And POCH is parent and child. So how many parents and how many childs? And how many siblings and how many spouses? So is this categorical or is this continuous? Continuous or categorical? Continuous? Well, it depends, right? You can only have 1, 2, 3, 4, right, which is discrete. You can't have 1.5 babies or 1.5 parents, right? So it depends on your choice. So it's your choice now. So I'm not going to do it. I'm just going to treat it as continuous. So I'm not going to do it. Ticket? Should I separate ticket? Right? There's too many. So no, don't do that. Cabin. Should I do cabin? Depends. I'm just going to try. Let's see what happens. And what's the last one? Embarked. Yep, embarked, yeah, because there's only S, C, and Q. Right, these are your columns, right? So we put it into a list, if you remember. Right, and this is your column lists. And you just put it here. And once you call that, only the columns that you ask for it will be factorized. Right, so P class 1, P class 2, and so on. Okay, so this is our new factorized data. Now, after I factorize it, what do I want to do with the name column? What do you think? What do I want to do with the name column? Should I remove it or what? Because does name mean anything? Like, if everyone's name is unique, what does it do to the algorithm? How can it detect trends? If everyone's name is unique, is it useful or not useful? Not useful. So I delete it, right? I don't want it. So how do I delete columns? Use pop, right? Pop means to delete the whole column. You can also use del, but I'll just use pop. So you do x.pop and you just do name, right? And once you do that, the column is deleted. Right? And once your column is deleted, if you try again, right, name is gone. What else do you want to delete? I don't want ticket, right? Ticket's horrible. You can also do this. This is another way. You can do del, which means delete, instead of the pop. Remember to only run it once. If you run it again, right, it will be error message. Why? Because ticket's already deleted. If it wants to delete ticket again, it's not even there, so it will be an error message. So ticket's deleted.
Notice that the variables which we're deleting, they have no impact on our prediction. For example, your name doesn't mean anything. Your name doesn't determine whether you survived or not. Like, there's no correlation. And same for your ticket number. There's no correlation, so be careful when you choose what to delete, because there are certain variables which you might think have no correlation, but they actually do.
Yeah.
But in this case, it's common sense. Like, your name doesn't mean anything for whether you survived or not.
True.
We're focusing on important factors such as your cabin class. Obviously related to real life, cabin class is important because those who are in first class got priority on the limited number of lifeboats and so on. And that's important for our prediction.
Yep, you're gonna.
So what if the prefix of the ticket was useful? How would I separate the prefix of the, like, let's say those prefix identify the zone, how would I take that
So
out?
just the prefix.
Yep.
Oh yeah, so for example, yeah, I get what you mean. So in the name, right, what happens if you want to separate just Mr.?
You can use
And misses.
there are functions to take strings from a particular length to another.
Yeah, so, I think that's a bit too complicated. Like, so you said ticket, right? Oh wait, we already deleted that. Oh, wait, give me a second. Where's the ticket? Wait. Now let's do, where's the other one which I didn't delete? Oh yeah, I'll start again. Okay, so you said ticket, right? So what do you want to do?
So if there was, and then identifier, but in this case there isn't. Usually.
So like if there's like a 3 or a 2 or something.
Yeah.
Like zone 1.
Something which determines like some attribute.
Oh, okay, yeah. So for example, I'll try to do on the name one, right? Let's say that I want to get the Mr. out, and the Mrs. out, and the Mrs. out. This might mean something, right? However, it might be too complicated. You can in fact separate it out using the str method, right? So you can split it, right? So pretend I want to, anyways, this is way too, it's a bit like advanced currently, but you can do this. You can in fact get the first name of the column, or pretend I want to just get the misses, right? You can do this. So yes, Python can do that. Oh wait, I have to call that. Right, I got all the Mr. and Mrs., all of them out. I can do that. Right, I think, do you mean that? Like, I want to get like the first prefix? Yeah, you use this method. But this is a bit too advanced currently. But you should check this out.
Thanks.
But, yeah, it's a bit, yeah. Anyways, continue on. I delete the column for that, and I delete the name, right? I don't want those. So let's see what the data looks like. Right? It kind of looks like all numbers. How do I know 100% sure that all the data is numbers? So what can I do is I check the D types again, right? Oh wait, not the, I keep getting confused. Right? If anything says object, there's a problem. So how do I subset the things which says object? Oh no, that's okay, that's the dot. Okay, so uint means unassigned, don't worry about that. So I want to make it equals to object, right? I want to find the things which says object. Right? Obviously it says false, 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 false. But I want to just subset the ones which it is in fact true. So how do I do that? So what I do is this. Right? What this means is I get the true and false, right? I want to find, so dot index means I want to find. I want to find everything that is in fact true. This is what the syntax means, okay? So I have the true and false, true and false, true and false, but then I want to only get the true. So I do the dot index. You can't just do this, okay? This does not work. You can't just write true. Okay, this won't work. Okay? You'll still get this like long thing. I only want to reference the ones which are true. So I have to do something like this. And as you can see, there's nothing, which is good. Yeah. Oh yeah. You want to go? Oh,
I have to.
oh, yeah.
Oh, but this is just.
Oh, it should continue.
That's the training data.
Yeah, yeah. Oh,
Like if we have this, we have this five.
Separate this to 5. No, I haven't separated this. Just separate this to 5. We just continue. Oh, it's a. Oh, you want to?
There's a little bit of other stuff like transformations and stuff.
Oh, wait. Oh, wait, that was cool. No, you just type shut. Wait, should we do it? Wait, what is the second one? Wait, give us a second. Oh, you're not there. I don't, just. Oh, don't worry. You want to do the. You want to do
Train
it?
test with.
Oh, yeah, let's do it. Okay, so. Yeah.
So now what we're going to do is
Oh, should I just predict first? Oh, train test. Oh, just fine. No, not the data. X. Okay, so you want to.
okay. So we have So now that we have all our data cleaned, no missing variables, we've converted all our categorical variables into numbers. The next step is to partition our data set into 2 different parts. So we'll have X, which is a matrix of our
Oh, wait. Partition firstly. Oh, wait. Before that, what do you want to predict? Do I want to predict survive, age, what? What do you guys want to predict?
Survive.
Yeah, survive. So I need to take survive and cut the survive column out of the data, right? So how do I do that? Remember the pop function? Right, you just make this equal to y.
So y is our matrix of the dependent variable, which is what we're trying to predict. So if you just run y now,
It would just be 1, 0, yeah.
it's just the survive column.
Yep.
This is just the index, and these are the values for survived or not, where 1 is survived, 0 is
Not
didn't survive. And we also create a matrix X, which contains our independent variables. So that's everything.
I'll just type X. Right, the survive column is gone.
So these are all of our independent variables. So we need some function. This is in the machine learning algorithm. Some function which will map all of these to a value of 1 or 0. And so we put this in our matrix X. It's already there.
Yep.
We have X. So we have X and Y. This is called splitting our data into test and training sets.
Yep, let's do that. So in machine learning, right, you have to split the data into training data and testing the data. Oh, wait, yeah, sorry. So why do I need to split the data into training and testing data? Right? So if I just train the whole model on just the training data, so if I train the whole model, right, just make the model like this, something like this, right? If I train the whole training data just with X, right, the original data, that's going to overfit, right? I'm using the whole data just to train Y, which is not good.
So just to explain overfitting, overfitting is basically where if you use 100% of your data just for the purpose of training, then it's not going to be able to make accurate predictions. It's like the best analogy I can think of is when you're studying for an exam, you're learning concepts, right? Because you don't know the exact questions in the exam. So in this analogy, overfitting would be memorizing each and every single question, each and every single number. So for example, let's say you're integrating tan x from 0 to 1. If you overfit, you just memorize the integral of tan x from 0 to 1. If the question in the exam asks you for the integral of tan x from 0 to 2, you won't be able to answer it if you overfit, because you memorized it from 0 to 1. So what we want to do is we want to make our algorithm essentially learn the concept so that it can apply it and make a prediction from that. So overfitting is basically when you memorize each and every single case. For example, this row survived, this row killed, this row survived. You don't want that. You want it to find some trends, just like when you learn integration, you want to understand what you're doing, so you can apply it to many different questions. So overfitting is not ideal. And the standard rule in machine learning is we split our data into
2 sections.
80% and 20%?
Yeah, 80% training and 20% testing.
So 80% for the training data, 20% for testing. So our algorithm runs on the 80% of the testing data, and it uses whatever it learned from there, and then applies it to the remaining 20% to make a prediction.
Yeah.
And you can check your accuracy from that, whether it's correct or how good the accuracy is.
This is correct. Yeah, okay.
Yeah, training.
So the function to split your data into 20 and 80%. Okay, you don't need to choose 20 and 80, but convention is 20 and 80. Some people do 60, 2/3 and 1/3, so 66 and 33.
Yeah.
Or 34. But
You should
normally 80-20.
Beyond that, yeah.
Yeah.
80-20 is preferred.
Don't do 10-90, that's also not a good idea. Because that means you're kind of overfitting as well. But try to do like 15-ish at least, okay? And the function to call is from the scikit-learn library. Remember the one of the 3 pillars of machine learning, data science, pandas, scikit-learn, and NumPy, right? So now we're going to use scikit-learn. And the module is called model selection, right? And I want to import train test split. So this is what you type and you press Control Enter, right? Likewise, if I don't want to name it so much, right? If I want to just remember the NumPy as, right? I can just do as split. However, the other term which people use is called hold out. I want to hold 20% out. So I'm just going to use hold out. Okay? Oh wait, I didn't have. Right, once I do that, I can call the function now. Right, hold out. Right, I want to split this and test size. The test size is 20%, right? So 0.2. And once you write that, you get something, right? It will be splitted. So how do I put this into variables? It will be x trained, right? I think it's
X train,
Y train,
X test, Y train.
yeah, I think so. Anyways, do this, okay? If you can't remember the order, just go online and you just type sklearn.
Train test split.
Yeah, you just type well, this is what we always do. If you can't remember the order, you just copy paste. Right, you just go down, oh, this is the function, go down, there you go, train test. Oh, see, I even got the order wrong. It's the train data, and then the testing data, and then the target variable. See, I even got that wrong. So, it's supposed to be this. Anyways, remember to copy paste from the internet. You don't want to get stuff wrong. Right, this is what it's supposed to look like. Okay?
So now you have four matrices. This is all the training data for your independent variables. This is the testing data for your independent, and training for your dependent, and testing for your dependent variable.
Yeah.
So X train and
So let's just see what it looks like.
just visualize.
Right? It looks like this. So the order is shuffled on purpose. Right? And X test will also look like this. So this is your testing. Y train. Right? And Y test. That's good.
So what's going to happen is when you're implementing your machine learning algorithm, you have X train and Y train. Those two matrices will be inputs into your machine learning algorithm.
Yeah.
And from there, it will learn the relationships between these variables to predict whether we have survived or not. And then it will apply that to the testing data set. So after it's learned from these two, this and this, it will apply itself to X test and make predictions, either 0 or 1, and then you can compare that to Y test.
Yeah. Okay.
And that will give you the accuracy.
Yeah. Okay, so we'll be doing, has anyone heard random forest before? Anyways, the most favorite, I don't even know if that makes sense, the most favorite machine learning algorithm of any data scientist or machine learning expert is random forests, right? It should be the first model you ever apply.
It depends on what you're doing, but
Normally random forest should be
random
right.
forest is good.
Right? So remember, survive is classification. I want to classify it as 0 and 1. So what do? So I use sklearn library, right? And it's called ensemble. The module is called ensemble. And I want to import, right? It's called random forest classifier. Right? Because I want to classify. Okay? If it was regression, if I want to do like numbers, then I have to do regressor. So what is a random forest? A random forest is like a dichotomous tree. It's like if I go to a forest and I want to know which tree is which, I get like the book, you know the book which says like, oh, if the leaf looks like this, go to page 10. If the leaf looks like that, then go to page 100 and so on. A random forest will make the model like that for you. Right? So let's do that. Right? Similarly, I don't want to keep calling random forest classifier. So in convention, it's going to be called RFC for shorthand. Okay? And then I want to train the model. How do I train the model? Well, module is equal to RFC. Right? And you put your parameters in between here. But don't worry, we're not going to use any parameters. And then you do model.train. Right? And then your X train, remember, and your Y train. So the X train is your input data, your Y train is the target. Control enter. Huh? Oh wait, yeah. Oh wait, sorry, it's not fit, it's fit, sorry. Yeah, I keep getting confused. It's fit, not train. Fit. Yeah. And it was something like this, right? All this garbage, whatever. Who cares? Don't worry about that.
They're all
The parameters. You can change the parameters later. And then remember, once I train the model, I want to predict, right? So I do predict the X. Remember the testing data? And then this is the prediction. Right? So after training the 80% of data, it predicts on the 20%. But what is the accuracy? Right? Let's say that I want to make it equal. So I want to find how many is correct. Right? So I do equal to the Y test. Right, and divide it, and then get the sum, right? I want to add them all together. Divided by this is just maths, the length of Y test. You got 82% accuracy. Just not doing anything. We just did some basic stuff, and you got 82% accuracy. So that's good, kind of. In machine learning, if you see 80-something% accuracy, that's good. If you see 90% accuracy, be careful. It's overfitting. Okay, normally it's it doesn't mean it's actually overfitting. But sometimes just be careful. And if you see less than 80%, maybe you're doing something wrong. Normally it's 80-ish%. So 79, 80, 81. So as you can see, 82 is quite good. We haven't done anything. So one more thing, to change the parameters, we can make more. So remember the dichotomous book? We can make the book fatter. How do we do that? Just put
100. It's 10 currently.
Oh, it is? Because I just did 1,000. Right, and it increased accuracy. It does not mean if you do like 10,000 it'll be good, because the training time will take.
It's not linear, so like it limits to some value. You can't just increase the number of trees to
a million or something.
Yeah.
Okay, yeah, that's all for today.
Yep.
But yes, if you increase 1% accuracy,
That's really good.
yeah, that's actually fantastic. If you increase 0.01% accuracy, that's fantastic as well. Okay, it's very hard to increase even by 0.01%. But yeah, that's all for today. Thanks.
Can you get a handout?
Oh yeah, I'll post. Yeah, just remind me. Post it on something and I'll do it.